Guys, this is Shelby with the Rogers Public Library. So we're doing a science experiment today. What you need for this experiment is a watermelon, a bunch of rubber bands, like several hundred, maybe 300 to 500-ish. And you also want to get some protective gear, like I'm wearing goggles and I'm wearing an apron to keep my clothes clean. And we're obviously doing this outside because it can be messy. But what we're doing is we're putting rubber bands around the middle of the watermelon, and we're going to keep doing this until it explodes. Which is going to take a lot. That's why you need a lot of rubber bands. But first, I want to talk to you guys a little bit about the science of how this works. So I want to explain to you how a rubber band works. And to understand how a rubber band works, you also need to understand something called entropy. But we're going to talk about the rubber band first. So this is made out of rubber. There's different kinds of rubber. There's synthetic rubber, which comes from plastic or petroleum products. But this is natural rubber, which means it comes from a tree called the rubber tree. And we use natural rubber for rubber bands because it's a little bit stretchier. But all rubber bands, they're called elastomers. And elastomers are polymers. And polymers is just things that, they're like little chains of things, little tiny molecules and stuff. But the way that the molecules are arranged in the rubber band, it makes it so when you stretch it, it comes back, right? And that's pretty unique. But the reason that this happens is because of something called entropy. And specifically something called the second law of thermodynamics. Now, there's a bunch of words on this page. You don't need to know them. But it's just, I think the diagram is neat. So it says there's two boxes, and one of them is hot and the other one is cold. The hot air will flow into the cold box, and they'll mix together and they'll be the same temperature. And so we can see something like that happen with this, right? So we have hot bricks and cold bricks. They're the same temperature, but it's a visual effect. When we shake it up, they get mixed together, right? And I can keep shaking this up for as long as I want, but the hot bricks aren't going to go back to the bottom and the cold bricks aren't going to go back to the top. That's what entropy is. And so a rubber band, if you stretch it, it gets hot, right? You can test this against your forehead. It gets hot when you stretch it, right? And that's because what the rubber band is doing is when it's stretching, it's going into what's called a low entropy state, right? So all the molecules in the rubber band are very stretched, they're very taut, and they're very ordered when you do this. Kind of like the jar was before we shook it up. And when you release it, it goes back into a low entropy state. And when it does that, it also gets cold. So there's the forces of entropy working here, but there's something else too. And that's thermal energy, right? So that just means heat. So when you stretch a rubber band, it gets hot. It releases energy. It's getting hot because it's releasing energy from the bands, right? And it's getting cold because it's absorbing energy. Or you can say when it's stretching back, it's using energy. It's absorbing energy, it's using energy to make motion. This is actually the same thing that happens when you spray an aerosol can. If you notice, if you spray like spray paint or something, the can gets cold. That's because the can is using the thermal energy in the atmosphere to expel gas, right? This rubber band is using the thermal energy in the atmosphere to do what's called work, which is just force plus in a direction. That's a little more complicated. We don't have to talk about that. But anyway, so that's how a rubber band works. And so when we stretch it over here, right, the rubber band is now in a low entropy state, but it wants to return to high entropy. That's what the second law of thermodynamics means. So right now, it wants to return to high entropy, and so it's going to be exerting the same force that we saw when it expands. It's trying to contract, just like we saw before. And one rubber band by itself doesn't contract or with a lot of force, but when we start adding the rubber bands together, it's going to be a lot of forces, and there's going to be so much force that the watermelon isn't going to be taken anymore. So this next part is boring. I'm just going to keep putting rubber bands on the watermelon, and in a little bit, we'll see what happens. Shooting watermelon juice at me. Okay, so that took about an hour and a half. A lot longer than I thought. I don't know that this half is edible, but we still have a lot of watermelon left that we can eat. So, yeah, that was fun. So the goggles were a good idea, right? I didn't mention this earlier, but this is really something that you want to have an adult to help you with. Just because it can do that, right? It can blow up and hit you in the face, and you just want someone there so that if something goes wrong, you can blame them. Also, you probably want to have someone help you put the rubber bands on. I got a couple blisters. Maybe that was just me. Yeah, but that was our experiment. It was pretty fun. So if you're going to be getting a lot of rubber bands to do the rubber band watermelon challenge, there's also some other things you can do with them, including some crafts. So you might know that stamps are made out of rubber, just like rubber bands are, because it's kind of absorbent and you can use it to stamp ink or paint onto things. You can also make your own stamps with rubber bands and frames. So this is one that I had made. It didn't last very well. It's all warped, so I'm not actually going to use it today. But I've made some other ones too. This is from some popsicle sticks that I glued together. I put the rubber bands over them. And I'm just gonna dip it in paint. It's a little bit easier, and you can kind of see it makes some interesting patterns, like so. There's some others I want to try out. This one, it's a little dough roller. I stuck rubber bands on it, and so we can make kind of different patterns. So it's still not a stamp, but it's similar. Like this. So you can get some nice textures this way. Also, this one is a mason jar lid, the outside part. And I'm going to dip it in this yellow paint, and you can see how it looks. In the paint that I'm using, this is just tempera paint. Sometimes they sell it as poster paint, and I watered it down a little bit so that it would stick better. I wouldn't get big globs in different areas. So you can use this stamp making technique and combine it with other things. So like for instance, this is one that I made, and it's dried now. I think I used acrylic for this one and not tempera, but I had some some newspaper that I'd stained. I combined it to make a little montage or collage. And then this is another one. It's more tempera paint, but it's kind of neat looking. So you can get different stamps and different paints and try to combine them and see what cool things you can make. But yeah, that's our craft for this week. See you guys next Thursday for Full Steam Ahead.